Hello and welcome to today's webinar on Generative AI for Autonomous IT and System Optimization Next-Gen AI Operations 2025. So, the first slide is about Generative AI or what is Generative AI. Generative AI refers to a class of artificial intelligence technologies capable of creating new content such as text, images, audio, code, or simulations based on patterns learned from vast datasets. It uses advanced machine learning models, particularly large language models, and generative adversarial networks to understand context, replicate styles, and produce outputs that closely resemble human creativity. By learning from diverse data sources, generative AI can generate realistic content, answer complex questions, and assist in sophisticated problem solving tasks that once required significant human effort. Generative AI enhances productivity by automating creative and knowledge intensive workflows. It helps organizations produce marketing content, design prototypes, draft legal documents, and generate code snippets in seconds. This reduces manual workload, accelerates content creation, and allows teams to focus on innovation and strategy rather than repetitive tasks. Through natural language understanding, generative AI supports conversational interfaces, enabling human machine interactions that improve user experience and accessibility. Real-time reasoning capabilities allow generative AI to provide intelligent recommendations, optimize business processes, and support decision-making with contextual insights. When integrated with enterprise systems, generative AI can analyze operational data, produce detailed reports, and highlight trends or risks that might otherwise go unnoticed. Predictive text generation, automated summarization, and intelligent search functions enhance knowledge management across the organization. In software development, generative AI accelerates development operations and CI and CD workflows by generating boilerplate code, identifying bugs, optimizing functions, and suggesting architectural improvements. It supports rapid prototyping, reducing time to market for new applications. Its adaptive learning mechanisms continually refine output quality based on feedback, improving accuracy over time. Security teams benefit from generative AI's ability to detect anomalies, simulate attack scenarios, and generate threat intelligence reports. By understanding patterns in cybersecurity data, generative AI strengthens defenses and improves incident response strategies. In customer service, AI powered chatbots and virtual assistants deliver personalized 24 by 7 support, improving satisfaction and reducing operational costs. Generative AI significantly enhances creativity and design. It assists artists, writers, game developers, and designers by generating concepts, visual assets, storylines, and blueprints tailored to project needs. In scientific research, it accelerates discovery by generating hypotheses, modeling molecular structures, and simulating complex systems. Healthcare applications include generating clinical summaries, assisting radiology workflows, and enabling personalized medical insights while maintaining data privacy through synthetic data generation. Across industries, generative AI enables scalable automated content pipelines that align with business objectives. Its ability to integrate with cloud services, data platforms, and enterprise applications make it a foundational technology for digital transformation. Organizations adopting generative AI gain operational efficiency, reduced costs, enhanced innovation, and faster execution cycles. By 2025, generative AI is becoming indispensable not only for creative tasks but for strategic decision making, automation, and competitive advantage. Traditional manual approaches to knowledge work cannot keep pace with modern digital demands. Generative AI transforms businesses into proactive, data driven enterprises capable of rapid adaptation. It empowers teams with intelligent tools, fosters collaboration, and unlocks new opportunities for innovation. With continuous learning, scalable architectures, and growing multimodal capabilities, generative AI serves as a catalyst for enterprise wide growth and long term digital resilience. Now, the next slide is about why generative AI is critical in 2025. Generative AI is critical in 2025 because the pace of digital transformation has accelerated beyond the capacity of traditional tools, requiring intelligent systems that can create, reason, and adapt in real time. Organizations face unprecedented complexity in their data ecosystems, and generative AI provides the advanced capabilities needed to manage, interpret, and utilize this information effectively. With businesses operating across cloud, on-premises, and edge environments, generative AI becomes an essential engine for unifying data, streamlining workflows, and enabling rapid decision-making at scale. Its ability to generate high-quality content, automate tasks, and provide contextual insights allows enterprises to maintain agility in a marketplace defined by constant change. As customer expectations rise, generative AI delivers personalized experiences that would be possible to achieve manually. It supports conversational interfaces, dynamic content generation, and intelligent recommendation that enhance engagement across digital platforms. This level of personalization is crucial in 2025 as organizations compete not only on product quality but also on the responsiveness and adaptability of their customer interactions. Generative AI bridges this gap by understanding user intent, predicting needs, and delivering tailored solutions instantly. The technology is also vital for addressing the growing skills gap. Many industries struggle to keep up with the demand for specialized talent, especially in fields such as software development, cybersecurity, and data analytics. Generative AI acts as a force multiplier, enabling teams to accomplish more with fewer resources. It automates coding, supports troubleshooting, and assists with architectural decisions, allowing developers and engineers to accelerate innovation and focus on higher value problem solving. In sectors where expertise is scarce, generative AI ensures continuity, efficiency, and faster execution. Cybersecurity threats in 2025 are more sophisticated, frequent, and automated than ever. Generative AI plays a crucial role by analyzing massive volumes of threat data, simulating attack patterns, and identifying anomalies in real time. Its predictive capabilities allow security teams to stay ahead of attackers, enhancing resilience across digital infrastructure. Automated threat intelligence generation and proactive detection mechanisms give organizations the defensive strength required to operate safely in an increasingly hostile cyber landscape. In research sector, health sector, and engineering sector, generative AI accelerates discovery by modeling complex systems, generating hypotheses, and providing simulations that reduce experimentation time and cost. This is especially critical in 2025 as industries strive to innovate faster while managing rising operational demands. Generative AI supports precision medicine, drug discovery, and clinical decision making with unprecedented accuracy, helping healthcare providers deliver better outcomes and personalized care. From an operational standpoint, generative AI ensures consistency, quality, and scalability across business processes. Automated document creation, workflow orchestration, and knowledge extraction reduce bottlenecks and eliminate human error. Organizations that rely on manual methods struggle to keep pace with increasing workloads, but generative AI offers the scalability needed to maintain performance under growing demand. Its integration with enterprise platforms, ERP, CRM, ITSM, and more creates unified intelligent systems that optimize operations end to end. Generative AI also enables real-time strategic decision-making, supporting leaders with data-driven insights, simulations, and forecasts. In a world where market conditions shift rapidly, companies must be able to evaluate scenarios and respond immediately. Generative AI's ability to synthesize data, generate reports, and surface actionable intelligence provides a competitive advantage that traditional analytics cannot match. By 2025, the global economy is deeply interconnected and digitally dependent, making adaptability a key determinant of success. Generative AI drives this adaptability by offering continuous learning, multimodal understanding, and dynamic content generation that evolve with business needs. It empowers organizations to innovate faster, reduce operational friction, and deliver superior value to customers. Ultimately, generative AI is critical in 2025 because it transforms businesses from reactive to proactive, from manual to automated, and from data-rich to insight-driven. It acts as a foundational technology that supports growth, enhances resilience, and enables organizations to compete and thrive in an increasingly digital world. Now, the next slide is about generative AI for autonomous IT operations and systems optimization. Generative AI is emerging as a transformational force in autonomous IT operations, enabling systems to predict, prevent, and resolve issues with minimal human intervention. By leveraging large language models and advanced generative algorithms, organizations can automate complex IT workflows, generate real-time insights, and optimize performance across cloud, on-premises, and edge environments. Generative AI brings the capability to interpret system logs, configuration data, infrastructure metrics, and operational patterns to create actionable recommendations that improve efficiency and reliability. In autonomous IT environments, generative AI enhances observability by synthesizing data from monitoring tools, service dashboards, and event streams. Instead of manually searching through logs or alerts, teams receive AI-generated summaries that highlight root causes, performance anomalies, and emerging risks. This accelerates incident response, reduces downtime, and ensures that critical services remain stable even under unpredictable workloads. Generative AI augments traditional monitoring by providing contextual explanations that make troubleshooting faster and more accurate. Generative AI also revolutionizes predictive maintenance by modeling system behavior and forecasting failures before they occur. It identifies resource bottlenecks, degraded components, and performance trends that would be difficult or impossible to detect manually. These predictive insights help IT teams schedule maintenance proactively, optimize capacity planning, and ensure that systems maintain peak performance across dynamic environments. Automated remediation workflows allow issues to be fixed automatically, preventing service interruptions and improving service delivery. In optimization scenarios, generative AI analyzes compute, storage, network, and application utilization to recommend or execute intelligent adjustments. It generates optimization strategies for load balancing, auto-scaling, and resource allocation based on real-time demands. This level of automation enables organizations to reduce cloud spending, eliminate waste, and improve energy efficiency. Generative AI-driven orchestration ensures that hybrid and multi-cloud environments remain aligned with business policies and performance requirements. Within development operations and CI and CD pipelines, generative AI accelerates deployments by generating tests, identifying code vulnerabilities, and predicting deployment risks. It automatically evaluates changes, analyzes dependencies, and ensures that updates are deployed safely and efficiently. By generating infrastructure as code, templates, documentation, and configuration policies, generative AI improves consistency and reduces operational overhead. This integration enhances agility, shortens release cycles, and reduces the likelihood of deployment-related outages. Security operations are strengthened as generative AI detects anomalies, simulates threat scenarios, and generates real-time incident intelligence. By analyzing behavioral patterns, access logs, and threat indicators, it provides early warnings and recommended actions to mitigate risks. Automated threat modeling helps organizations build stronger defenses and respond faster to emerging security challenges. Generative AI ensures that IT ecosystems remain compliant, secure, and resilient. For IT service management, generative AI automates ticket handling, knowledge retrieval, and workflow execution. It interprets incoming requests, generates accurate responses, and even executes back-end actions to resolve common issues autonomously. AI-generated runbooks and resolution summaries improve knowledge sharing and reduce the dependency on manual support processes. This leads to faster resolution times, reduced support costs, and higher user satisfaction. Generative AI also enhances data-driven decision-making. It synthesizes operational intelligence into executive-level reports, translating complex technical data into insights that guide strategic planning. With the ability to evaluate thousands of scenarios and optimize configurations dynamically, generative AI empowers IT leaders to make informed, proactive decisions that align with long-term organizational goals. By 2025, the scale and complexity of IT ecosystems require systems that are adaptive, autonomous, and self-optimizing. Generative AI delivers these capabilities by combining automation, predictive analytics, and contextual understanding into a unified operational framework. It moves IT teams beyond manual firefighting and reactive approaches, enabling a future where systems manage themselves, learn from experience, and continuously improve. Ultimately, generative AI transforms IT operations into a proactive, intelligent, and resilient environment. It ensures optimal performance, strengthens security, and accelerates innovation while reducing operational costs. As organizations navigate digital first demands, generative AI becomes a critical pillar for sustaining growth, ensuring reliability, and unlocking the full potential of autonomous IT. Now, the next slide is about reinforcement learning for autonomous IT. Reinforcement learning is becoming a foundational technology for autonomous IT operations as organizations move towards systems that can adapt, optimize, and correct themselves in real time. Reinforcement learning enables machines to learn through continuous interaction with IT environments, making decisions based on feedback and improving performance with each feedback or each iteration. Instead of relying solely on predefined rules or static automation scripts, reinforcement learning based systems evolve dynamically, learning the optimal actions to maintain reliability, efficiency, and stability in complex IT infrastructures. In autonomous IT ecosystems, reinforcement learning agents observe the state of infrastructure servers. In autonomous IT ecosystems, reinforcement learning agents observe the state of infrastructure servers, applications, networks, databases, security controls, and take actions that drive the system toward desired outcomes. These outcomes might include reducing latency, balancing workloads, preventing failures, or enhancing resource utilization. Over time, the reinforcement learning agent identifies which actions produce the best results and builds a policy that improves autonomously. This adaptive learning capability is essential in 2025, where environments change rapidly and workloads fluctuate unpredictably. Reinforcement learning plays a critical role in intelligent resource optimization across cloud and hybrid environments. By analyzing utilization patterns, performance metrics, and workload behavior, reinforcement learning can make real-time decisions on autoscaling, load distribution, and capacity allocation. Unlike traditional threshold-based scaling, reinforcement learning continuously evaluates the impact of its actions, ensuring optimal resource use while minimizing operational costs. This approach allows organizations to maintain service level agreements even during peak load events or sudden traffic surges. In predictive maintenance, reinforcement learning enhances system resilience by learning to anticipate failures before they occur. By experimenting with different policies such as moving workloads, rebooting components, or adjusting configurations, reinforcement learning determines the best course of action to maintain uptime. These self-correcting behaviors reduce downtime, prevent cascading failures, and ensure mission-critical applications remain available and responsive. Reinforcement learning also strengthens automated response. Reinforcement learning also strengthens automated incident response. Reinforcement learning agents can be trained to detect anomalies, apply remediation actions, and verify the results, all without human intervention. Over time, the system becomes more effective as it learns which solutions resolve which type of issues. This reduces mean time to repair, improves reliability, and frees IT teams from repetitive troubleshooting tasks. Reinforcement learning driven remediation brings true self-healing capabilities to IT environments. In development operations workflows, reinforcement learning optimizes deployment strategies by learning from past successes and failures. It evaluates the outcomes of different deployment methods, tests, configurations, and delivery timings to minimize errors and maximize stability. Reinforcement learning can also tune CI and CD pipelines by adjusting test selection, optimizing build resources, and reducing bottlenecks. This accelerates release cycles while maintaining high quality and reducing deployment risk. Network management benefits significantly from reinforcement learning as the technology optimizes routing, bandwidth allocation, and congestion handling. Reinforcement learning agents adapt to real-time conditions, ensuring that data flows efficiently even during unexpected spikes or failures. In distributed and edge environments, reinforcement learning becomes essential for coordinating resource decisions across devices that operate independently yet require consistent performance and security. Security operations are also enhanced by reinforcement learning's adaptive capabilities. Reinforcement learning systems learn optimal responses to threats, testing various mitigation strategies, and reinforcing those that minimize risk. This dynamic defense model is far more effective than static rule-based systems, especially as especially as cyber threats continue to evolve. Reinforcement learning can adjust firewall rules, detect deviations from normal behavior, and autonomously quarantine suspicious activities, ultimately strengthening overall resilience. In IT service management, reinforcement learning optimizes ticket routing, automation triggers, and workflow prioritization. It learns from historical patterns to predict the fastest and most effective way to resolve issues, improving service quality and reducing operational costs. Reinforcement learning driven chatbots and virtual assistants also refine their responses over time, providing more accurate and context aware solutions to users. By 2025, the rapidly growing complexity of IT ecosystems makes traditional management methods insufficient. Reinforcement learning provides the adaptive intelligence required to manage dynamic systems at scale. Its ability to learn from experience, adjust policies, and optimize outcomes without human intervention makes reinforcement learning a cornerstone for achieving fully autonomous IT operations. Ultimately, reinforcement learning drives IT environments toward self-optimization, self-healing, and self-protection. It empowers organizations to maintain high performance, improve reliability, reduce costs, and accelerate innovation. As businesses become increasingly digital first, reinforcement learning serves as a key enabler for resilient, intelligent, and future-ready IT operations. Now, the next slide is about Python programming language and R programming language. So first, I am going to make you all familiar with Python programming language. Python is the language of choice for modern analytics, AI, and software development. Its clean syntax makes it accessible to beginners and powerful for experts. Python's versatility spans data analytics, web development, automation, and AI applications. Pandas and NumPy enable fast, efficient manipulation of structured and numerical data. SciPy and stats models provide advanced statistical and scientific computing tools. Matplotlib and Seaborn create clear, informative static visualizations for reporting. Plotly, Bokeh, and Altair allow interactive dashboards and web-ready visualizations. Python integrates seamlessly with scikit-learn for predictive modeling and machine learning. TensorFlow and PyTorch power deep learning, neural networks, and AI research. Jupyter Notebooks and Jupyter Lab combine code visualization and narrative in one platform. In finance sector, Python drives algorithmic trading, portfolio optimization, and risk analysis. Retail sector uses Python for customer segmentation, demand forecasting, and recommendation engines. Healthcare sector leverages Python for predictive diagnostics, bioinformatics, and imaging analysis. Big data processing is supported via PySpark, Dask, and Hadoop for scalable analytics. ETL automation is simplified with Airflow and Prefect for robust workflows. Flask and Django enable web applications, APIs, and microservices for enterprises. Streamlit and Dash turn Python scripts into interactive dashboards instantly. Cloud integration with AWS, Azure, and Google Cloud ensures scalable deployment. Python automates reporting, notifications, and monitoring to save time and reduce errors. Package management with pip and conda ensures modular, maintainable projects. Python's strong documentation and global community support rapid learning and innovation. Open source contributions drive continuous improvement and cost-effective solutions. Educational institutions teach Python to build coding, analytics, and AI skills. Geospatial analysis is powered by GeoPandas and Folium for mapping and visualization. 3D modeling and simulations use Mayavi, Plotly, 3D, and Matplotlib extensions. Time series forecasting and anomaly detection are streamlined with Prophet and Stats models. NLP capabilities come from Spacey, NLTK, and Hugging Face transformers. Python integrates with SQL and NoSQL databases for efficient data storage and retrieval. Data storytelling combines visuals, interactivity, and analytics in a single workflow. Scientific computing benefits from Python in physics, biology, and engineering research. Rapid prototyping and agile development are natural with Python's lightweight syntax. Web scraping with Beautiful Soap and Scrappy allows automated data collection. Cybersecurity applications include threat detection, automated testing, and monitoring. Cross-platform compatibility ensures smooth deployment on Windows, Mac OS, and Linux. Python unifies data processing, AI visualization, and automation in one ecosystem. Its simplicity, flexibility, and scalability make it the universal language of modern analytics. Python drives innovation in AI, cloud computing, real-time analytics, and data engineering. Its growing ecosystem and active community secure its place for developers, analysts, and researchers. Python is not just a language, it is a tool for transforming data into insight, action, and value. Now, the next Now, I am going to make you all familiar with R programming language. R remains one of the most powerful languages for data analysis, statistics, and visualization. Its syntax is designed for statistical computing, making it ideal for analysts and researchers. R provides a vast ecosystem of packages that extend its capabilities across industries. Data manipulation is streamlined with packages like dplyr and data.table for efficient workflows. Tidyverse unifies data cleaning, transformation, and exploration under a consistent framework. Visualization is one of the R's strongest suits, with ggplot2 providing elegant layered graphics. Shiny allows analysts to create interactive web applications and dashboards with ease. Plotly for R adds interactivity and real-time data visualization capabilities. R integrates smoothly with machine learning packages such as Carrot, MLR3, and Tidy models. Advanced AI and deep learning are supported via interfaces to TensorFlow, Keras, and Torch. R Markdown and R notebooks combine code, results, and narrative for reproducible research. In finance sector, R powers portfolio optimization, risk modeling, and algorithmic strategies. Retail analytics leverages R for customer segmentation, demand forecasting, and sales insights. Healthcare uses R for clinical trial analysis, predictive diagnostics, and bioinformatics. Big data processing is possible through Spark R and integration with Hadoop ecosystems. ETL and automation pipelines can be built using R scripts and workflow packages. Interactive dashboards and applications are deployed with Shiny server or cloud-based hosting. Time series analysis is streamlined with Forecast, Prophet, and Sybil packages. Our statistical modeling capabilities enable linear, non-linear, and mixed effects models. Spatial and geospatial analysis is supported via SF, SP, and Leaflet for mapping solutions. Data storytelling is enhanced through R's visualization, reports, and interactive outputs. Natural language processing in R is supported through tidy text and text mining packages. R connects with SQL and NoSQL databases for structured and unstructured data analysis. Simulation, Monte Carlo methods, and stochastic modeling are native strengths of R. R is cross-platform and runs smoothly on Windows, Mac OS, and Linux systems. Package management via CRAN and Bioconductor ensures access to thousands of libraries. Reproducibility is at R's core through scripts, R Markdown, and project-oriented workflows. Automation scripts can handle reporting alerts and scheduled analysis efficiently. R's open source nature drives continuous innovation and community support. Academia widely uses R to teach statistics, data science, and analytical reasoning. Visualization extends to 3D plotting, interactive maps, and network graphs in R. R supports integration with APIs, cloud computing, and modern data pipelines. Its flexibility allows analysts to move from data cleaning to advanced modeling seamlessly. Shiny and Flex dashboard enable rapid deployment of interactive applications. Data visualization, modeling, and storytelling are unified within a single R workflow. R's ecosystem and statistical foundations make it indispensable for data-driven insights. Its combination of analytical rigor, visualization power, and community support ensures longevity. R continues to evolve, powering analytics, research, AI, and decision-making across sectors. R is not just a language, it is a statistical powerhouse transforming data into actionable insight. Now, the next slide is about generative modeling. Generative modeling is a core branch of artificial intelligence focused on learning the underlying patterns, structures, and relationships within data to create entirely new outputs that resemble the original data set. Unlike traditional predictive models that simplify, classify, or estimate values, generative models simulate the data distribution itself. This enables them to produce realistic text, images, audio, code, and even complex simulations. By understanding how data is generated, these models can produce novel outputs that maintain coherence, accuracy, and contextual relevance relevance. Generative modeling relies heavily on deep learning frameworks such as variational autoencoders, generative adversarial networks, autoregressive transformers, diffusion models, and normalizing flows. Each architecture approaches generation differently, but all share a common goal: to learn a representation of data that can be sampled to create new high quality content. This capability allows generative models to act as engines of creativity, automation, and problem solving across industries. One of the most powerful aspects of generative modeling is its ability to learn from high dimensional, unstructured data, images, natural language, audio signals, and sensor outputs. Instead of manually engineering features, generative models discover latent representations that describe the essential structure of the data. These latent spaces can be manipulated to produce variations, combinations, and entirely new forms of content. This flexibility makes generative modeling a foundational technology for modern AI-powered creativity and analytics. In enterprise environments, generative modeling automates content creation workflows that once required significant manual labor. It can generate synthetic training data, create product designs, draft documents, and simulate business scenarios. These capabilities accelerate innovation, reduce operational overhead, and ensure consistency across large-scale processes. With the ability to produce endless variations, generative models also enable personalization at scale in marketing, customer experience, and digital product development. Generative modeling plays a critical role in simulation-based optimization and decision support. Models can simulate network performance, IT infrastructure behavior, financial market trends, and manufacturing processes. These simulations allow organizations to test hypotheses, predict future outcomes, and evaluate strategic decisions without risking real-world consequences. This is especially valuable